Frequently, we need to remove certain elements of a list in a process known as filtering. We visit each element and ask a question. If the question answers true, we keep the element. If it's false, we ditch the element. The question is asked with a predicate function, something that consumes the element and returns a Boolean. So here we see the signature of the filter function built into language. It consumes an x, a function that consumes an x and produces a Boolean, and also a list of x. Applies the function to each element in order to produce a new list of x. The list of x is unchanged except for the fact that some elements might be removed. Let's start by filtering out even numbers from a list of numbers. So we call the filter function and pass in a function like evenha. Now evenha is a function. If we pass it an odd number, it returns false, and we pass it an even number, it returns true. So if we apply filter evenha to a list 1, 2, 3, 4, it's applied to each element, and the ones that are false are rejected, in which case we end up with a list 2, 4. There's a similar function called oddha that we can use, 1, 2, 3, 4, and that produces the list 1, 3. What about removing strings that slipped into a list of numbers? So if we have our numberha function that checks to see if a given value is a number or not, we pass it a list where there are numbers and strings intermingled. This produces the list of just valid numbers, 1, 5, and 7. You could do the same thing with stringha. We can define our own functions that can be used in our higher order functions. So let's say we wanted to go back to our book example before and find all the free books, the books that cost no money. So we'll write a function called freebookha that consumes a book and produces a Boolean, consumes a book and produces a Boolean indicating if the price of the book is 0. Define freebookha as a function that consumes a book, and if the price of the book is 0, then return true. We'll write a quick check expect, or 2 perhaps. We know that the first of the books was Harry Potter, and that cost $9.99, so that'll return false. We'll take advantage of another built-in function, very convenient, called third, and the third book in the list was Hamlet. That one was free. You'll notice here I'm using first and third. There's also second, fourth, fifth, bunch of built-in simple functions. Anyway, we have our free book function. We test it to make sure it still works. If it does, we can then apply the function to a list of books and find the free ones. So we'll write filter free books on the books list, and that passes back just Hamlet. You'll notice that when we call this function, it doesn't produce Booleans or the book price. Common misconception. It's still producing a list of books. Each book is still a make book. It's just removed the books that we weren't interested in, the ones that were not free. You gotta remember the way that filter works. It's the one that, it doesn't produce Booleans, it produces a list of the same type.